Everybody tell me what is the two parts of the soap molecule? Everybody, one is what? Hydrophobic end, and another one is what? Hydrophilic. So hydrophilic end is the hydrophilic end, means note it everybody, COO minus Na plus. This is what we used to call it as a hydrophilic end, which will attract what? Water or dirt? Everybody. Which will like to attract what? Water or dirt? Which will attract like to water. It's a water loving. And hydrophilic end, that is what we can say alkyl end, or which is actually a tail part, which likes to bond with the dirt. So that is why you can see, you all notice it here. This is the most important paragraph. I'll explain you word to word. You have to observe. So as we left it here, we'll continue from there. So the soaps are molecules, thus form a structures, call it as a micelles. So what is the meaning of micelles? That is very important. So all of you observe the ionic end of the soap. What is the ionic end, everybody? Hydrophilica, hydrophobica? Hurry. Hydrophilic or hydrophobic part? Ionic end. Negative and positive charge, guys. Which end? Hydrophilic or hydrophobic? Please respond. Hydrophilic end is called it as a ionic end. Array, how many times I am saying, but still nobody is saying. So ionic end of a soap interacts with the water, while the carbon chain, that is what we can say alkyl, or it interact with the oil. Please note it, everybody. So if you see the figure number 4.12, you all notice it. The tail part is attracting by the oil, and the positive part, the ionic part, is repulsion away from the oil. So that is what is how the soap molecules are present. So soap molecules means two parts you have to remember. One is hydrophobic tail, and another one is hydrophilic head. That is you have to remember. So now, where one end of these molecules is towards the oil droplet, while the other ionic end faces outside, this forms an emulsion in the water. Emulsification of fats. What do you mean by emulsification? Biology you studied emulsion. Anybody can tell? Emulsion. All of you? Emulsion means making the fats into small balls. Am I right, guys? Digestion chapter, biology. Do you remember, Amma?
Yes, sir.
Girls?
Breaking down of food.
Yeah. What is emulsification? Biology, what you studied? Tell me, everybody. Like,
Sir, emulsification of fat cell gallbladder.
yeah, what will happen? That will make breakdown of the fats, and it will converting into what? Small balls. Like, that is what we can say
Yes.
globules, like Aishwarya said. So the same thing will happen here. As the tail part is attracted by the oil, and head part, the hydrophilic, is attracted by the water. So what will happen? The ionic end is facing away from that. That is what you can see. Faces outside, and tail part, that is what R, alkyl group, is facing towards the oil droplet. So this forms an emulsion in the water, means they will form the small molecules. The soap will break it into small molecules or aggregates. That is what we used to call it as micelles. So please learn the definition of micelles. You can see here, the soap molecules thus forms the structures, call it as a micelles. So what is the micelle? So what is micelle? Where one end of the molecule is towards to the oil droplet, and other end is ionic faces outside. So they only will help the fats to break down, that oil to break down. So that is what the small structures of soaps, which we used to call it as a micelles. Write it, everybody. When soaps dissolved in water, micelle definition. When soaps dissolved in water, when soap is dissolved in water, then a colloidal solution will form. So we all know colloidal solution means, you might be remember immediately, where you studied colloidal solution. Colloidal solution, this year also physics somewhere it came. Anybody can tell? Human ion colorful world. Do you remember everybody? Atmosphere is a colloidal solution. Am I right or wrong? Yeah, Tyndall effect. Very good, Manikanda. So colloidal solution, Tyndall effect. So colloidal solution is formed due to the formation of due to the formation of a smaller aggregates. Smaller aggregates. Sir, what is the smaller aggregate? This is what. So wherever oil drops is there, so soap molecules will dissolve, it will be separated, and tail part will go and will react with the oil surface, and head part is showing the repulsion, means it is attracting towards to the water. So that is the molecules which we used to call it as a micelles. So all of you write it. Smaller aggregates of soap molecules which are called, what is to call everybody, which are called micelles. Okay, so now in this micelle, two things you have to remember again. Hydrocarbon part, that is what hydrophobic, tail are directed towards the what? In this micelle, the tail is directed towards the what? Oil surface of water, everybody. Please remember, tail is directed towards to the center. Center means towards to the oil, and ionic ends are directed outwards. So the ionic ends are directed outwards because the negative charge, if you have noticed it, basically the same charge will shows repulsion each other. So that is the reason the ionic ends are always will making repulsion to each other. So they will always acting outwards. So they will never combine together because of same charge. They will shows what? Same charge means they will shows repulsion or attraction. They will shows repulsion. That is what you have to remember. So hydrophobic part also you can write is alkyl group. Alkyl group means what is to call hydrocarbon part. Hydrocarbon part. Also we can call it as what is to call tail part. Note it everybody. So now this is what is like a structure of micelle. All the tails are towards to the center and positive charge ionic part is away from the each other. So that is what you have to remember. Okay, guys, everybody clear? All of you? So now I'm talking about the micelles. That is only our today's class. We'll continue from here. So soaps are molecules in which the two ends have different properties. One is hydrophilic, already we studied. That is interacts with what? Water or dirt? Everybody. Hydrophilic, head part. Head part is a what? Attracting towards the water or oil, amma? Yes, please. Attracting interacts with the what? Water. And while the other end is hydrophobic, that is, it will interacts with the hydrocarbons. It will interacts with the hydrocarbon. Who is the hydrocarbon? That is what the fats, the hydrates of fats, carboxylic acids, whatever it is, that dirt you have, the dirt contains basically what? They are oily in nature. They contains the hydrocarbons only. That is why when soap is at the surface of water, the hydrophilic tail of a soap will not be soluble in water, and the soap will be aligned along the surface of water with the ionic end of water and the hydrocarbon tail protruding out of water. So means in the sense of, if suppose if I have taken a water, this is my water. Now if I dissolve the soap now, so which is interacting with the water? No dirt is there. Can you tell me? No dirt is there means by the time who is attracting the water? Not dirt. Dirt is there means tail part will attract. If there is no dirt, so who will attract the water? Everybody? Head part or tail part?
Head part, sir.
Head part will attract the water and tail part is showing the away from it. That is what, which is protruding out of water, means showing it is not mixed with the water. It will be coming, projecting outwards from the water. So that is how it will be happen. So when the soap is aligned with the surface of water, at the surface, the positive node is attracting towards the water, and negative node, the tail part is projecting outwards, out of water, because positive charge is only reacting with the water surface. But inside water, this is at the surface. Remember that. Inside water, what is happening? So that is what very important. So inside, these molecules have a unique orientation that keeps the hydrocarbon portions out of the water. Now, if you notice it here, whatever the clusters of molecules, that is what we can call it as a micelles. The clusters of molecules, which we used to call it as a micelles, you can see, in which the hydrophobic tails are in the interior of the cluster and the ionic ends are on the surface of the cluster, because ionic end is what? Positive, that is what? A charged particle, which is attracted by water, which is attracted by water, which is attracted by water. And all the tail parts, they don't like, they will never like to react with the water. That is why all the tail parts will shows interior of the cluster. If I consider, this is what we used to call it as a cluster of molecules, which we used to call it as a micelles. So this formation only, all the tails are interior and all the charged particle, hydrophilic is outwards, hydrophobic tail is are interior of the cluster. That is the cluster we used to call it as a micelle. So whenever the soap you are applying to your cloth or your surface, they will form the micelles. That micelles only they were able to clean the oil surface or whatever the dirt you have. So since the oil dirt will be collected in the center of the micelle, that is very, very important. So entire oil will be collected at the center of the micelle. You can notice it here, everybody. So the soap is dissolving, they are forming into the small particles, everything. That is what we can say micelles. And this micelles, all the tail is attracting. You can see here, all the tail is attracting, and every direction they are attracting this oil surface, and they are turning up into what? You can see a cluster of molecule. All the heads are away from it, and all the tail is attracted by the oil drop, and that together they will fight with the oil. They will attract the oil and they will take out from the surface. So this is our cloth, a dirty cloth or your hand, whatever it is. So they are attracting, you can see all the tail is attracting towards the oil surface, and they will turn up into a cluster, a molecule, and they will take away from the surface. You can see here. Now here there is no contact with the surface, means it is removed. So this micelles, the oil dirt will collected only at the where, everybody? At the center of the micelle. That is what in this picture you can notice it. At the center only the oil drop will be collected. All the directions, the tail part, hydrophobic part will attack this oil droplet and will remove it from the surface. That is what it will be happening. Now, these micelles stay in the solution as a colloid and they will not come together. So colloidal solution, you might be remember that. Particles, colloidal substances. So what is colloidal substances? Particles will never settle down. Particles neither come up nor go down to settle. So that is why the particles are always floating. So they will never settle up or down on the surface or bottom because of Actually, the particle, generally if you take the colloidal solution, the particle size is between 10 nanometer to 100 nanometer. So when the particle size is between them, so they are having the same size of the water. So like we can say, they will always floating inside it. They will never come up or they'll never go down. Same thing will happen here also. So the micelles stay in a solution as a colloid. They will never go down. They will never become together and they will never come up also. So they will not come together to precipitate, because what do you mean by precipitate? Anybody can tell? Precipitate means what? To become into what? To become into what, guys? Precipitation reaction we studied means to become a solid. So they will never become together because ion-ion repulsion. So all we know, all the ions is having the same charge. If this ion wants to come to here, if this ion wants to come to here, so they all will be having the same charge. So this same charge will always will source what? Attraction or repulsion? They will source repulsion each other. So that is why they will never come together to form the precipitate. Very, very important question. So they always, micelles will always stay in a solution as a colloid because their ion-ion repulsion. They will never come together because of same charge always will source repulsion. Now, the dirt which is suspended in the micelle is also easily rinsed away. That is how it will be taken away from the cloth, and the soap micelles actually they are having a big enough size to scatter the light. That is what we can see. We all studied the Tyndall effect in the physics. So Tyndall effect means, what do you mean by Tyndall effect? Anybody? First, what is the meaning of scattering of light? We all studied physics. Anybody? Scattering of light, splitting of light into all the
Splitting of lights.
splitting of light into all the
Sir.
directions, which we used to call it as a scattering of light. Am I right? Am I right? Please respond, everybody. Correct, Amma?
Yes, sir.
When the light is coming in a particular path, the scatterers which are present in its path, they will split that light into all the directions. That is what is called as a scattering of light. Now, because of micelles, as they are having a sufficient size, so they are not too small or too large, they are fixed normal size, which is enough to scatter the light. So that is why the soap solution always appears to be what? Everybody? What is the reason? Cloudy. Understand, Amma? Because what is happening? The micelles will scatter the light. They will spread the light in all the directions. That is the reason the soap solution always appears to be what? Everybody? Appears to be cloudy in nature. So cloudy means you all knows, will experience it. Today is a very heavy cloudy, going to rain like that will say. So that is the, because of it is appears to be cloudy only because of scattering of light, the physics phenomena. So who will scatter the light? Micelles. So that is how it will be happening. So this is what is about the reaction of soap in our cloth. Whenever your mother or you are trying to wash your hand, your cloth or whatever it is, the soap will break into small aggregates. That is what we used to call it as a micelles. And this micelles, all the tail part, hydrophobic part is interior of the cluster, and the hydrophilic part is the outer or exterior. Understanding? Like we can say, is exterior of the cluster. So that is why they are on the surface. They are the surface of the clusters. Ionic ends are very important. Ionic ends are on the surface of the cluster. So that formation is only we used to call it as a micelle. And at the center of the micelle only, oil drops will be collected. All over, whatever the dirt you have, that is will be collected. It is. So this is how it will be. You can actually, the dirty cloth will be agitated or you rubbed. So how it will happen? Just if you soak in the water, all the micelles will form and the dirt is ready to remove. Just if you rub with your hand or a brush, or if you agitate it like washing machine, then this dirt particles present in the form of micelles, they will just wash it away, or they will disperse in water, and the surface become very clean. That is how our hands are, or our cloth, whatever it is, they will be basically cleaning like this process only. So this cleansing is depends upon the rinsing with the clean water and the amount of grease or dirt present in the surface of the cloth. So that is also very important. That is the reason till today washing machine means no problem. But normally, have you noticed it? Before washing the cloth, our parents will rinse the cloth for a certain period of time, or they will soak in the water. Have you remember everybody? Please respond, guys. Soak in the water. Why they will soak in the water? That is based upon the amount of dirt present on the cloth. Suppose if the cloth is, suppose daily you are wearing, your cloth is not required to soak. Simply you can go for washing, it will be cleaned because very less amount of dirt will be there. But if it is like we can take 4 days, 5 days, if you take like daily wakes people and all, their shirts is very horrible to wash because they're having large amount of grease and dirt. For them, definitely the cloth need to soak in a clean water, or normally with the detergents for a certain period of time, then only it is easy to wash. Otherwise, very tough. So this is what is about how this will be forming. The only 2 points you have to remember. One is tail part is attracted towards to the dirt. That is what hydrophobic end, and head part is attracted towards to the high water. That is what hydrophilic end. So that is what head part is always COO minus Na, and the tail part is R. This is the tail and this is the head. That is what you have to remember it. So till here you complete it. Then from here we'll continue in the next class. So from activity 4.11, it is another important concepts. Only that. So if you have been finished this, then this concept is over. So this is all about it. So soaps and what is the limitations of soaps and all, we'll discuss it. And next class we'll start the detergents and we'll finish it. Okay. So with this, I'll stop and we'll continue in the next class. Thank you, everybody. Do well, prepare, and we'll meet in the next class. Thank you, all of you.
Thank you, sir.